Hi, my name is Josh, and today I'm going to be talking to you about how mechanical engineering can contribute to the exploration and development of the Arctic. Engineering is the application of mathematical and scientific principles to better our society. Often, this involves extracting natural resources and developing them into useful products. So, what resources exist in the Arctic? Forestry? Human resources? More like oil and gas, an Albertan's favorite word. So how much of it really exists in the Arctic? This map shows estimated oil reserves. Current estimates put 13% of the world's undiscovered oil in the Arctic Circle. And so, that brings us to the topic of my presentation, offshore Arctic drilling. Being able to send a rig out on the ice-ridden sea is a feat and a true pinnacle of mechanical engineering. In this presentation, I'm going to talk about the types of Arctic environments, the types of Arctic offshore rigs, and how each rig type is suited for a different environment. The Arctic environment provides many challenges to the already difficult task of drilling a well offshore. Cold weather as low as minus 70 degrees Celsius, fog, and limited sunlight pose significant challenges. In the high Arctic, it is also very remote, making bringing supplies to a site a task on its own. The Arctic is also environmentally sensitive. With low biodiversity, the few species of plant and animal life are more sensitive to human impacts such as habitat destruction and oil spills. Oil spills have the potential to be extremely harmful since response times can be lengthy due to the remoteness. Periodic sea ice poses one of the greatest challenges. Its dynamic loading conditions can cause havoc to any vessel that it comes across. There are three main types of Arctic environments: Arctic, subarctic, and winterized. Arctic environments include places where ice covers the sea year-round. Subarctic environments experience occasional sea ice, and winterized climates experience little to no sea ice, but still see harsh temperatures. It is important to choose a rig most suited to the environment drilling will take place in. There are three categories of rigs capable of Arctic drilling: the jackup type, which is secured to the ocean floor, ship-shaped, which float freely, and semi-submersibles, which provide a hybrid between the two. The first rig type that will be discussed is the jackup type. The main selling feature of the jackup type rig is that it is securely mounted to the ocean floor, providing a sturdy platform. It is limited to depths of 50 to 80 meters, not only because of the associated cost, but also due to the force of the ice. Using a bit of Civi 270 talk here, the dynamic load of the ice on the legs causes both a massive moment that tries to overturn the platform, but also tremendous shear force in the legs. The picture on the right features a jackup type rig used in the Maritimes, and if you look closely at the legs, they resemble a lattice structure. These lattice type legs perform poorly in the Arctic conditions because they are vulnerable to sea ice loads. Jackup type rigs that are used in the Arctic feature tubular legs that better combat sea ice. Semi-submersible rigs can sometimes provide a more practical solution to drilling a well than jackup type rigs. In harsh environments, they provide an advantage over jackups due to their superior motion capability. However, they are still subject to sea ice loading, mainly the jamming of sea ice between columns. Semi-submersible rigs also have a relatively low travel speed, making them impractical in remote areas such as the high Arctic. Drill ships are the most mobile type of rig. They are effective when rapid deployment is required. Their mono-hull or single-hull design can be superior to the multi-hull design of a semi-submersible because of its ability to handle ice better. Drill ships provide a solution to drilling wells in water deeper than 80 meters and in more remote locations. It is important to understand how the rig stays where it needs to be, right above the well. Jackup rigs are secured to the ocean floor with giant legs, but what about semi-submersibles and drill ships? There are two main categories of ship positioning: dynamic positioning and mooring. Dynamic positioning involves constantly running the engine to keep the ship positioned. It allows for the quick startup of an operation, but requires large thrusters to battle the ice and in turn uses large amounts of fuel. Mooring is when strong steel cables are extended outwards and attached to the ocean floor. That brings me to the end of my presentation. Throughout this presentation, I spoke about how different types of offshore rigs are suited to different Arctic environments and water depths. Every aspect of these ships includes mechanical engineering, from the dynamic loading conditions imposed upon them to the drilling equipment on board. Without such technology, the exploration and development of oil in the Arctic would be impossible. Thank you.